Here's a section that I really like, linear approximations. All right, watch this trick. How much is the square root of 9? You're right, it's 3. How much is the square root of 9.09? Does it equal 3.03? Makes sense to me, doesn't it? The square root of 9 is 3. Well, the square root of that 9 is 3, and the square root of that 9 is 3. But is it correct? The square root of 9.09. 3.015. Nope, I didn't get it right. So, how can we use calculus to figure out this? So, linear approximation. Let's say that you start with the function. In this case, the function that we're dealing with is the square root function. But instead of square root of a number, just look at the square root of x function. So the square root of x function looks like this. And now we go out to where x is a 9. And if you plug that in to the square root function, as we saw right there, the square root of 9 is 3. Then what we're going to do is, at this point, you find the equation of the tangent line. And as you can see, the difference between that red line and the black function, there's very little difference, especially if you stay very close to 9. If you're over here, they're starting to veer apart. But right in here, they're very close. So the first thing to do is, at 9, 3, we're going to find the equation of the tangent line. So in order to find the equation of a line, we need a point, and we also need the slope. Well, the slope is going to come from the derivative. And the derivative of the square root of x function is 1 over 2 times the square root of x. Now all we need to do is substitute in the 9. So the derivative when x is a 9 is going to be 1 over 2 times the square root of 9. Or in other words, the slope of the tangent line, this is going to be 3 times 2 in the denominator, so the slope is 1/6. So the slope of this red line is 1/6. And then we could use the point slope formula and go y minus the y value of 3 equals the slope times x minus the x value of 9. And then I'm going to go ahead and distribute this 1/6, so it's going to be 1/6 x minus 9/6. And then add 3 to both sides. So the equation is going to be 1/6 of x. And then how much is, well, let's see, this, I should reduce it. So divide by 3 and divide by 3. So that's going to be -3/2. And then for this 3, I could write it as 6 over 2. So y equals 1/6 x. And then when you combine these, it's going to be 6 minus 3, so it's going to be plus 3/2. All right, now finally, take this 9.09 and substitute it in. So basically we're taking 9.09 right here, and then we're substituting that into the red line, and the difference between the red line and the black function, there should be very little difference. So then y equals 1/6 9.09 plus 3/2. So this is my approximation for the square root of 9.09. So it's 1/6 of 9.09 plus 3/2. And the estimate is 3.015. So as you can see, at least for the first 3 decimal places, it's perfectly accurate. Now, you might just say, well, why don't we just use the calculator right there? Very good question, and you could. But the beauty of this is you're taking something that's more complicated, like most humans cannot take the square root of 9.09 by themselves without a calculator. This, I could even do that math without a calculator. So we're taking something that's more complicated and replacing it with something that is simpler. So basically, this function right here is a simpler version, and it will give you a good estimate as long as you're close to that 9. Okay, then let's do another example. Guess this is going to be example number 2. So estimate sine of 3, and this process is called linearization. Which is just sort of a long, fancy word. But if you look at the root of it, it's just saying use a line, the equation of a line. First of all, we need a function. So the function is going to be sine of x. Now, sine of 3, I don't know what that equals. But if I pick something that's close to 3, like pi, 3.14159, etc., 3.14, it's pretty close to that. And I know what sine of pi is, even without a calculator, because I know that the sine graph looks like this from 0 to 2 pi, and pi is right here, so sine of pi equals 0. So just with that, my estimate is the answer is going to be pretty close to 0. This is 3.14, so 3 would be right here, so it's going to be some small positive number. But I can get even better estimate than that because I can do the linearization. So we need the derivative, and the derivative of sine is cosine. And then plug in that x is going to be pi. So that's going to be cosine of pi. And I could even do that without a calculator because I know the graph of cosine looks like this from 0 to 2 pi. And so cosine of pi, it's equal to -1 down here. So that means that the slope is equal to a -1. And this information over here is saying that the point is x is pi and the y value is 0. So now we have all the pieces that we need to find the equation of the tangent line. It's going to go y minus the y value of 0 equals the slope times x minus the x value pi. And then I can simplify this one pretty easily. The left side's just going to be y. The right side's going to be -x plus pi. And the last thing to do is plug in a 3. So this is going to be, x becomes a 3, so it's going to be -3 plus pi. And so that's going to be negative 3 plus 3.14159, however many decimals you want. So the 3's are going to cancel each other out. And because this one is bigger and it's positive, the answer is going to be positive 14159, etc. So that is my estimate for sine of 3. Now, let's look at the actual answer. Sine of 3 is equal to, make sure it's in radians, good. Sine of 3 is equal to, so as far as the first 3 decimals, yep, that looks right. Let me put some more decimals on here. Sine of 3 is, so the actual answer is 0.14112, etc. So for the first 3 decimals, it is correct. So that's not bad considering it's such a simple function. It's just negative x plus pi, such a simple function that's estimating the sine function as long as you're close to pi. Now, I just want to show you, some people do it a slightly different way. And that is, they basically do all of the algebra in abstract instead of like I was using the point slope formula. In that case, the formula looks like this. So that's basically saying, go ahead and do all of this in abstract, and you're going to end up with this equation right here. So this equation right here, it has, this is the slope, so that comes from the derivative, so that's this part, and then there's the x minus a, and then this is just the y value. So this one was a 0, but they moved it over to the right side. So for example number 3, we'll use this formula. What is the cube root of 8.1? All right, first we need the function. So f of x is going to be the cube root function. And then you pick a number that you could even plug it in there without a calculator, and you could do the cube root of it. It needs to be close to this and something that you know the cube root of. So the cube root of 8 is 2. So the y value, or in other words, the cube root of 8 is 2. So that's that part right there. So this is a 2. So in here, using this notation, I should have called this a instead of x. They call it a. There, I fixed it. All right, now we need the derivative. So it's going to be, well, first I should rewrite the function as x to the 1/3 power in place of the cube root, and then take its derivative. So that would be 1/3 x, and then subtract 1 from the exponent, so that's negative 2/3. And then since I'm allergic to negative exponents, I rewrite that as x to the 2/3, but in the denominator. And that's going to be this part right here, but I need to plug in the number 8 as well. So it's going to be 1/3 times, and then 8 is to the 2/3 power. So this number down here, the 3, that means take the cube root of it. The cube root of 8 is a 2. Now this is saying square your result. So 2 squared, that would be 4. And then 4 times 3 is going to be 12. So this is going to be 1/12. So using this method right here, it's going to look like the function could be approximated by f of a, so that was the y value, 2, plus the derivative, that's 1 over 12, times x minus the a, which is 8. And then the last part is plug in the 8.1. So f of 8.1 is approximately a 2 plus 1/12 of 8.1 minus 8. So 2 plus a 12th, and then 8.1 minus 8, that's just going to be a 0.1. So it's 2.008 with a bunch of 3's after it. And then how accurate was that? Let's see, math, take the cube root of 8.1 and 2.00829, that is pretty good. All right, so that is linear approximations, also known as linearization.